We're going to do some demos, but before I close off and turn it over to Tyler, I did want to mention this reference book. It's written by a personal friend of mine, but it's probably the best single book that I'm aware of on all the physics that I just discussed. And if you take the time to read and understand what he's got in that book, you'll be a real expert on analyzing camera systems, being able to talk authoritatively about qualitative as well as quantitative measurements. And believe it or not, there's a tremendous amount of things that you can do at home on a kitchen table with no special equipment with a camera. Like you can measure the full well, you can measure the read noise, you can measure the fixed pattern noise, and you can see what else, and the camera gain. You can measure all those things with no special tools. So with that, I will either open it up for questions, turn it over to Tyler for some demos,
any
whatever
questions?
you guys want to do.
You guys gonna get let him go like that so easily?
Some of our cameras that I showed on that little matrix at the beginning. So various different baselines.
The demos are live,
and
so
with
I think
and
you guys
without
just stand up.
illuminators. They're live demos. So
Please feel free to ask
kind of the best
questions.
thing for me to do is shut up and let you talk. Okay.
Can you steer that camera to?
Let me. I'll take care of the camera.
Okay. I don't know what I need to do.
You can do the demos, and I'll display it up there.
How about I just step out of the way?
Somebody want to step up?
Can you do a demo and then
Oh, okay,
show everybody?
okay, sure. I think my demos are pretty straightforward, right? So what I have here is
Can't hear you.
Microphone.
Osman, you got the mic?
okay. So what I have here is
Something's off.
is what we call an EX8036 module. It has a 6 centimeter baseline, so it goes from about 0.5 meter. It covers about 0.5 meter to about 4 meter.
Does that have HDMI or VGA output on your laptop?
It has. This one has Type C. This one has HDMI.
Yeah, it's plugged into the monitor.
Actually, this one's more cool because I have the point cloud set up on this one instead.
I don't think that
Do you have DP over on that one? Because I've got a DP adapter.
It's just Type C.
Oh, okay.
So just plug it in.
Good thing about standards, there's so many of them. Just pick one.
You can set the laptop on in the front of the podium. It works pretty well up there. I think, isn't that the flat, like Osman's got?
Sure, I'll take that one back.
Actually, I didn't want to move the camera around because I know it's going to break.
Working without a net.
Okay. So let me set this guy up. So how would I see it?
It's Mac. Anybody know how to?
It should be on here. It should be on the menu.
You got it?
Yeah.
Gee, that looks familiar. Screen too familiar, doesn't it? Yeah. I know that. Makes me think of something like 16.04.
That's not.
I think you have two screens, so you need to move that to the other screen if you want to show that.
Do an alt tab between switch between
Right.
programs.
There you go.
Yeah, he's at the extend screen instead of mirror.
I'm set up in
Change the screen mode?
yeah.
You know, can you just put the laptop on top and let the camera here take the image of it?
You're not proud, are you?
I want to get things done.
Is the one for selecting output. You can tell it to to duplicate instead of extend the screen.
You know what? Can I
Go
do
to
this?
that line.
Okay. We just want to see the depth map, so.
Yeah, just bring the test
Every video conference where it takes 15 freaking minutes to get that.
There it is.
I used to make
Almost there.
computers and data projectors.
Yay. Gotta be quicker than that.
I'm in extended mode, so.
Move it all the way over.
I think that's
You don't want to be
good.
in the extended.
Yeah.
Just leave it.
Quit while you're ahead, Kim.
That's right, man. And, oh, look at that. It's
So
like-
now let me, that's without the illuminator. Actually, the illuminators are turned on. So,
Yeah. It's like,
So that one's set up for a fairly close-in optimization.
yeah.
Right.
This one goes up to actually 3.5 meter.
You're using Etron?
Yeah, it's kind of hard to see. You have to look at the text data. The depth is there, but you don't see it visually.
Yeah, it's just how they do the gamma and the color conversion.
And on this, go ahead.
You do see
Trying to see my hand.
No,
Oh.
how come it's only good for 3 or 4 meters? You know, you've got 4 inches of separation.
Actually, we cap the output, the digital output. So it, it's maximum, I think about 4 meters.
Let me try
Because
to
on-
answer that.
Can you hear you?
Let me try to answer it. So there's sort of two problems here. He's getting a depth map, and then he's got to map that to a color scale.
Yeah.
And so the color scale may not be optimized to show subtle differences when you're far away. But if you saw it just as a linear table of numbers, you would see it in there. So if it makes sense, it's sort of like adjusting a gamma adjustment.
Well, I mean, you know, again, like the big push now is self-driving vehicles.
Right.
So, you know, is there any reason why we couldn't get more depth?
You can get the depth, the information's there, it's just optimizing the display. to
No,
show
his,
better.
his question is not on display. He's asking why are we capping at 4 meter? Why
Yeah.
can we not do 4.5 or 5 meters? And yeah. And the,
You can see the back of the room, you can see that there's a sort of purple haze. That's the back of the room, and you can see
Right.
all the heads of all the
That's
people,
right,
like, you know.
that's right.
okay, we have 2 modes. Okay, one is called disparity. This is a disparity mode. I'm going to switch to the absolute distant noise that we're working on. Okay, it's just on the display side. So hold on.
Thank you, Kim. Gotta bring one of your
Hey, it's my job. Somebody's got to do it.
Get the robot dance party out there.
Yeah, that's what I was looking for, dance party. We could use that in the room. Oh.
So this one, the output is actually absolute distance instead of disparity. You can see a little more, but it's a little bit noisier compared to the disparity.
So you can't make that stop.
On this top, I actually have a point cloud demo that I want to show. Actually, I was expecting to set up a demo here and people would come up and do selfies and stuff. I wasn't expecting this, so I have a Type-C output. And
Point the camera like that.
okay, let's do that.
I don't see you.
We're not gonna make this easy.
There you go.
Not at all.
Anyone want to come up and do a quick selfie? Want to do a selfie? A 3D selfie?
Quick question for you. Is there limitations just inherent in the technology for near field? Like, is it myopic within a certain range?
Can you repeat your question?
Is it half feet?
You said
Oh, sorry.
minimum range, half meter.
Half a meter, roughly half a
Is that
meter.
with your optics, or is that
They're,
just
they're
something
fixed
you do?
focus.
Yeah.
They're fixed focus and it's a function of the baseline.
So if you went from 60 millimeters to 30 millimeters,
So the baseline again is the distance between the two eyes. On this module, it's a 6 centimeter baseline. On the smaller module, we have a 3 centimeter, and the minimum is about 0.2 meter for that module. So it depends. It's a function of your baseline.
so based on your experience, is there like a limitation if you kept coming in? Let's say you wanted to get a little closer from 0.2.
Actually, we have another module. It's called multi-aperture. So we have 4 sensors at different baseline. So you can do like 0.1 meter to really, really far away, like 15 meters. To answer your question.
Could you do 10 centimeters?
Let's say you want to do 10 centimeters to 30 centimeters.
Yeah, you could. You just keep reducing your baseline. Yeah. Yeah.
If you really wanted to only have that limited range, you would change the optics to get an appropriate field of view, to focus in close like that, and then you'd set the baseline to be an appropriate distance for it. There's a lot of parameters to turn, but what we've typically done on these is they're focused in infinity.
And is that because in the near field you then start to essentially lose focus and therefore you can't distinguish features? That's basically why you have this problem.
Well, normally people want to have be able to see things at a long distance away,
Yeah.
and so they're set up for focus in infinity.
Right.
We could completely re-optimize the design for doing something different.
But it's
We could even have variable focus, but I'm not sure how the calibration of that would work.
right.
And the human eye's got variable focus,
Right.
but a fixed baseline.
But it's because the objects go out of focus and therefore you can't distinguish features.
Right. You've got to be able to match them up with the rectification.
Not quite. Actually, I wanted to make a comment about your question. And one of the issues is your pixel resolution, because when you're trying to determine the z-depth of an object,
Yeah.
you're measuring what's the pixel shift from the left eye to the right eye. And that's a quantized number. Of course, you can get sub-pixel mapping. So in my experiments, I remember showing a stereo demo like 3 years ago here at HPRC. You can actually, without changing your optic, if you just rotate the cameras so that they're not exactly parallel, you can actually change the resolution versus depth. Exactly. So I'm saying there are other solutions.
Like crossing your eyes. To look in close.
So it looked like you had a absolute distance mode, some kind of differential mode, and a point cloud mode.
No, actually, the point cloud is on the software side. But on the camera side, we have 2 modes. One is this parity, and the other one's absolute depth. So we do the conversion for you on the hardware at the hardware level, so you don't have to do it in software.
Those modes are a function of the chip?
Yeah, it's programmable. Yeah.
Is there more information available on the chip?
What kind of information?
Just how the modes work.
Oh, just how the mode work?
How the modes work, how to set it all.
Yeah, we have documentation on the API. If you buy the module, we give you the SDK, and we have full documentation for that.
How do we buy the module?
Chung, right there, he's our general manager on the US side, so.
We'll set you up.
He can take PO right now.
What kind of a frame rate do you get on publishing the?
Oh, it's 60 frames a second. Yeah. Go ahead.
What are you using for your feature extraction outside of just the projection?
We don't have feature extraction at the hardware level.
Okay.
Yeah, so you have to implement that at the software level.
So your so the disparity
So what we give you is the stereo image,
okay,
and the depth map.
Okay.
And the depth map has 2 outputs.
So
Disparity or absolute depth.
So you're doing dense stereo disparity calculations, and you're not extracting features and then finding the disparity.
Oh, you're asking about the algorithm.
Yeah.
Yeah, it's a corresponding problem, right? So I can tell you, I cannot go into more detail, but you can take a semi-global, local approach to do the pixel comparison.
Just checking, these are the $119 or $129 cameras, or is this a different
Ken, what's the...
Okay, so the price on this high resolution camera with the global shutter and all that stuff, right now we sell them for roughly $400.
Okay.
The other one out there, the smaller one, right now I'm selling for $199.
But that's, the other one is not a global shutter, correct?
That one's rolling shutter, okay? And that has, so we sell with and without illuminators. With the illuminator, that's the pricing with the illuminators. Okay? So that one is the rolling shutter, the older generation chip. Okay, that has high def video output with a BGA depth map. So this one has roughly 2K video with a high def high definition depth map.
Okay. So this point cloud right here, I just captured earlier. In fact, I just compiled the code like 20 minutes ago. So
He's been working with Chris a lot.
I took a stereo image and then a depth image, and then I fused them together to make this point cloud. So you can see it.
Yeah, the point clouds are really cool.
Yeah.
Any more questions?
So is this module currently shipping, or?
Yeah. Okay. So we're an IC company. Okay. So our biggest customer right now is Oculus. So this is the same chip that's being used in the Oculus Rift sensors. Okay. So the module themselves are a product that we help do our sales basically. And so those are shipping. I shipped several hundred of those already. This one is more prototype. I shipped maybe in the tens, under 100 so far, but getting close to 100. Okay? So if you want them, those are in stock in my Santa Clara office. I have a couple of this one available. Okay. The intention here is not to sell you guys, but okay, if you want to buy, we take credit card. Maybe I should give you a show discount here, right?
PayPal too, right?
I think you set up the PayPal.
It'll have to be okay to push your wares here. Okay. Oh, thank you very much. Those are good numbers.
Thank you. Thank you very much.
Thank you all.
Okay.